Hi there, everyone. My name is Aradhyula. I'm an AI platform engineering architect at Outshift by Cisco.
Hi, my name is Santana. I'm a senior specialist SA, solutions architect, working for AWS, and I'm also a CNCF ambassador, and also Argo contributor. So today's talk is going to be about revolutionizing Argo integration with MCP and AI-driven approach. As you can tell, I'm not smart enough to come up with that title, so I use AI. So we'll dig into what that means. So we'll start with the basic things about, is it joined?
If you can click on the button. Yeah.
I don't know why it's doing that.
Yeah.
Oh, what's wrong? I just went to slideshow.
Yeah, there you go.
Okay, so maybe it looks better now. So let's start with, maybe you have not seen this concept of using agentic or agents using the workflow of it. I just wanted to paint a simple picture. If you have not used this, but is the aspect of a user, starting with a user query of like, it could be something coding. A lot of people have seen these tools of Cloud Code or AI or Copilot. Raise your hand so I can have an idea. Okay. So it starts with a simple prompt, natural language, that you send to this agent, and this agent has access to an LLM. And basically, they do reasoning. That's the kind of like the new thing around these agents. They like reason around the, like sometimes they even text type thinking, right? They don't think, they reason. But they reason of like what are the things that they need to respond back, and sometimes they need to act with the real world. And that real world is access to tools. And tools is access to database, an API. And in this case, we're in KubeCon, so we're talking about DevOps, like a DevOps tool that can access our systems and act on it. So by acting on it, the agent will use a protocol, MCP, Model Context Protocol, that is a list of tools that are available. So it will be a combination of that agent going back to the LLM and saying, hey, these are the tools that I could use to answer the question or the prompt of the user. And then the LLM will say, use that tool, and by the way, use it with these parameters. And then this agent, which is a piece of Python code or Java code that does the logic, it will use that tool with this protocol, the MCP, call this tool, which is a method, and then they get the response back. And these are the type of way of all these agentic tools work. In simple terms, if you want to know the basics. And then from that point on, it gets more complicated or more advanced. So the reason I say this is because today we're going to talk about how do we make our integration with Argo better using agents, but we're missing the MCP tools in Argo. A few of them, like you saw this morning, Acuity has a Argo CD MCP, but what about Argo workflows and Argo rollouts, right? So I'll be showing a tool today around that. So the challenge is connecting AI agents to Argo APIs. The thing is, if you're going to start, for example, doing the work for Argo workflows, Argo CD, for example, the code that got developed for MCP is 103 operations or tool calls. For Argo workflow is 69. And then you have to do these minor integrations. You're going to sit down and start writing Python or JavaScript or whatever language you decide to write the MCP. You would use an SDK and sit down and like come up with like what are all the APIs that are available in Argo workflows or Argo rollouts or Argo CD, and then translating that into an agentic tool. And then also the communication, right? The problem of like these APIs that are, and when I say APIs that are available, are the Argo rollouts Swagger file, or OpenAPI spec Swagger file of the Argo project. And then what happens when the API gets updated? Maybe Argo rollout or Argo CD gets an update to their API, and then you have to go back and then do the legwork to update that code to make it like current. So your agents continues to work with the latest version of any of the Argo projects. So when I say Argo, in this case, if I say Argo CD, Argo workflows, I'm referring to any of the Argo projects. So what's the process to do this? So there's out there some tools that will take, for example, a gateway or proxy approach that will take an OpenAPI spec JSON file and then you can load it into this proxy called Agent Gateway, for example, is one implementation. If you search in the web for MCP gateways, or you will find a few implementations. Even from vendors, you will see those. And to a certain degree, if you have simple API specs, it works. But when we took a look, right, on Argo workflows, it doesn't work. It's the amount of that generated OpenAPI spec, it's not meets the criteria to be translated to MCP. So actually, it doesn't work. So if you're thinking of just taking a Swagger file and you will get an MCP just by doing this proxy approach of a gateway, it's equals to hope. It doesn't work. So with Cisco and the CNOE project and the K project, we came up with a tool to generate the MCP server. So I'm going to show you kind of like the very high level, and then we'll show you the Git code. So the first input to this tool, and it's a GitHub repo, it's available, it's open source, anyone can use it. And it doesn't matter if it's the Swagger file is from Argo or any API. It could be an internal API. You take the open-spec API.json with some configuration and then a prompt.yaml. And why do we have a prompt.yaml? It's because the next step we have what? An LLM. So we're going to use an LLM to be able to take all that information that is stored in the Swagger. And also, the LLM is trained with data that is available online. So there's data available online about Argo. So with the combination of the information on this OpenAPI spec, the information that the LLM has, for example, Cloud is one good one, we're going to augment and create a better version of that Swagger, enhance and be MCP compatible and also agentic compatible. And we're going to use an overlay to patch that OpenAPI spec file. And then the next layer or approach in the pipeline, so this is kind of a pipeline, is we're going to generate that enhanced spec by applying this overlay spec and then do code generation. So guess LLMs are very good in generating code, and agents are very good at using LLMs to generate code and then test that code. And if there's errors, it will fit itself. So it starts reasoning and acting on it to the point that you get that server code generated. And then the output of that code generation is basically an MCP server. So in a minute or two, suddenly now we have Argo rollouts and Argo workflows, MCP servers running, that then also we can generate for quick test or integration an A2A agent. Those are the two protocols when you work with these agentic workflows. If you're building an internal developer platform, you'll be working with those protocols, MCP and A2A. So here's just an example, like one of them of like before. So the Swagger from Argo workflows will have something like this of like perform an operations of list. Literally, that's what's in the Swagger file. So a developer would, like basically that's the API. But at the bottom, you see the LLM enhanced version of it that an agent will know what to do with this tool or this API, which is list all workflows in a namespace, and then use keywords that are like a standard way of using MCP. When do I use it? Use it when you need to discover running workflows or monitor workflows. And then what's required? Well, the namespace is required, that field. That way, this is a better enhanced documentation of that API than then we can create the MCP server. So let's do a quick demo on how this looks like, because we're talking a lot. So I have a CLI here. And I have Docker. So basically, we already went through the tool, created the MCP server. It's available as a Docker. So if I docker ps here, I have Argo workflow on port 3000. This is the code running in a container. And then if we open things like MCP inspector, who knows what MCP inspector is? Couple of you. So if you're working with an MCP server, basically like this is a quick way to inspect an MCP tool. So if I connect it connected, then I can do tools and list tools, and suddenly I have the 69 tools in Argo workflows that an agent or MCP client can use, and I can select one of them. I think I can do, is it version? A safe one to do? Let me see which one is safe here. I think there was one for version, right? That was,
Yeah.
I cannot see
right there.
This one, get info. I run it, doesn't take parameters, and then I run it, and successful, right? So this proves that the MCP server is up and running, is running in Docker. And then I have a little tool that is Amazon Q, that is like Cloud Code, but I have the MCP configure, and I can do /tools. And as you can see here, these are all the tools that is available to this tool agent CLI. And through MCP, we'll talk to the MCP server. So I can do things like list the last workflows, right? Just listing, and it will know which API to use to start using MCP, and it will give me back the workflows. And in this case, I'm running in a kind cluster, deploy Argo workflows. So as you can see here, it's already running that tool and giving you good output out of it. I can say create a workflow of hello world, if I can type, for ArgoCon, right? Actually, internet is up. I'm surprised. So this is, right, it creates an Argo workflow. It creates the spec, it sends that submit, and it's created. I can do show an example of Argo workflow template to show a new person in the team, how Argo workflows, I'm just coming up with the prompt, I don't know what works. And by the way, this person speaks Spanish. Whose second language is English here? Okay, a couple of you. Do you know that all these LLM tools can speak any language? Doesn't have to be English. So if you're learning Argo workflows, Argo rollouts, you can just learn in Spanish. Well, I don't speak Spanish. I speak Boricua. I'm from Puerto Rico, so I can say speak in Boricua using slang words, right? And keep it PG-13, I guess. So I'll show that, just to show that there's diversity in this type of tools, right? We think about like other people in different countries learning cloud native, learning Argo. So these agents are very useful to learn when you're starting a job or just starting a new technology, and your own language, the way that you like it, and also sometimes in the age that you have. So in this case, who speaks Spanish here? Hopefully one person, 2, 3, 4. So who can vouch that this is actually Spanish? Raise your hand, right? And it's Puerto Rican Spanish. So it's kind of like fun as you learned at your job. So that's what I wanted to show, of like a quick way of, now we have Argo workflows, Argo CD, and Argo rollouts that you can use from any agent, any tool that talks MCP. And I'm going to leave to Sri to see what they're doing in Cisco with using agents and A2A.
All right, so what you're looking at is my Git repo here. It's the OpenAPI MCP to CodeGen Git repo. I think Carlos just explained how when we started, I think there wasn't a solidly defined Argo CD server that came around after Acuity created it and donated it. We were also looking at Argo workflows, rollouts, and other cloud native apps that don't have readily available MCP servers. And we also couldn't trust all the supply chain that was out there. So we wanted to look at like what is the ingredients of creating the MCP servers, which starts with OpenAPI. But as Carlos alluded to, there are some challenges of just taking a raw MCP or OpenAPI spec and using as MCP. As noted here, LLMs have limitations on the length of your function, the size of your tool description. What we have done here is we kind of used agentic Gen AI to be able to give a very strong system prompt that says, hey, if you are using certain rules, for example, there are we've kind of defined these rules in the system prompt that'll tell there is a limitation of 64 characters. There is also a description length. And all of these are codified into the prompt itself. And also how do we truncate these functions, et cetera, et cetera. The end result is creating a set of, and also a few short prompts on what is a good function, what should be truncated, et cetera. As Carlos described, the end result of this, and this is one of the examples I'm running locally. I'm going to change the port here just so that I give you an example. So the OpenAPI spec to translation to these functions, they look something like this, right? Not only you get the MCP server that you can connect to and talk to, we also wanted to create like a readily available like A2A server. It's using any like standard available like SDK like LangChain or LangGraph or Strands, so that you can play with it and immediately get started. Ultimately, our goal is to be able to use in a project called Cape, which I'll talk about it in a second. So this is how our journey has been. So let me kind of go to the slides here real quick. And so just to kind of scaffold what Cape is. So Cape is a community AI platform engineering open source project we've been working on, part of Cloud Native Operational Excellence. The idea with Cape is that you have many platform engineering tools that you are using, especially Argo workflows, Argo CD rollouts, along with your Kubernetes, Jira, and other systems. We wanted to create a system that could talk to all of these MCP servers. In some cases, these are A2A agents, so that they can be run as just microservices, like containers, talking to this Cape as a deep agent, as we call it. So you can ask a question about, hey, show me all my unhealthy Argo CD apps, and debug with your debugging tool of choice, whether it's AWS MCP tool or some other observability tool like Splunk or Datadog or something like that. So basically, you are putting together different sources of data and being able to ask some intelligent questions. So with that, I'm going to jump straight into demo in the interest of time. So the first demo I wanted to show is a quick demo on, so the tool that we used for auto generation also generates an A2A server. So when I launch the A2A server, I have an MCP server that was shown earlier, and there is the artifact that generates the A2A server. So I'm going to launch it with the A2A server, and I will go full screen so you don't have to see the other parts of it. So this is a CLI we created that's called Agent Chat CLI. It can talk to any A2A server. So in this case, we quickly ran through creating the MCP and A2A. I'll show that in a minute. I actually forgot to do that. Here, I'll just say, what can you do? And all of the system prompt, the skills, everything else have been codified. It's also streaming the output from a GPT model. It could be Bedrock, Anthropic, what have you. I can say something like show the version. I'm talking to an Argo workflow environment, so it's able to get the version. It's also telling you which tool it's calling. That's pretty cool to see. I can say, show me the Argo workflows. That's another thing we wanted to capture is stream the tools that are coming from the MCP, going through the agent, and it says, okay, there are not. What about, because it's a conversational chat, and also the agent knows the context, I can say namespace Argo. So it should be able to say, okay, in Argo, I'm able to find these things, and it's going to stream that back. It sounds like it did not have any. We'll move on. I did capture a short video that I can show in a minute. moving on to this setup. So what I wanted to show here real quick is how does this tool actually generate the MCP and A2A server, right? So there's a make target here, and you could just do make generate something like Argo workflows, and there is one for agent. There is also evaluations you can generate, workflows, and I'll do one for agent so that we can see that. So what it's doing under the hood is it's going to use like your favorite LLM of choice, and then use the system prompt and a config to take the OpenAPI spec that's literally from the Argo workflow server, and put all of that together and finally generate a MCP and Argo CD, A2A server. So just kind of closing that on that. So we've been using these examples in our Cape project, and we've committed some of these examples here. So you'll see that in Argo workflows there is a generated code section, and there is all the tools that were generated. We just regenerated a little while ago. And you'll also see the protocol bindings that we use. And there are some common libraries that we created that are part of Canoe that we are using. So last but not least, I wanted to show you how all of this ties together.
Cisco. At Cisco.
At Cisco, yeah. So all of how this ties together at Cisco. So I'm going to kind of create a new chat. So this is what you're looking at is a Backstage plugin we open sourced called Agent Forge. So Agent Forge is a plugin that you can talk to any A2A compatible agent. We open sourced it because there wasn't one that was readily available. And Cape is the project that puts together a lot of the different MCP agents you can run yourself and bring your own, or enterprise agents, and ask intelligent questions to Cape. So in the interest of time, I'll see if I can get the Wi-Fi to work efficiently. If it doesn't, I'll do a video demo. So I can say, okay, what can you do? This is a UI that we've been iterating over, and it's an open source project, so you'll see some of the latest and greatest things. So it's streaming what it can do. And it says, okay, these are all the things it can do. It really can do these operations because we have created in some cases we're using upstream MCP servers like GitHub or AWS. In some cases, like Argo CD workflows, we're using the ones that we created first party, including PagerDuty. So here I'll say something like, show me Argo CD apps list, right? I can even query on which ones are unhealthy and get through and get to ask like additional questions. So here you're seeing it creates a task list of things to do, and this is what Cape is good at. And it's streaming all the relevant stuff. It's going to tabulate all of that info, and you can further query on additional things, et cetera, et cetera. So those are some things that are happening there. In the interest of time, I will put together a video. There is a little bit of a situation there, but I'm going to just run through this real quick, and then we'll go into Q&A. So here I asked a question, okay, find me all the Argo CD apps for Jarvis and Cape that are unhealthy. This is running on one of our internal systems. So it goes through, and it's running these things in parallel. So it actually can query these Argo CD apps in parallel. It's doing a search for those. It streams everything, but that's not fully structured yet. So it's going to stream everything and puts them together in a structured format. And then I did go and say, okay, can you tell me more about a specific event? And then you can follow on and say, I need to know what events there are for this unhealthy app. So that's on the project. I'll do a quick closeout here on the slides. So we've also had scaffolding to show on LangFuse. So if you are interested in using LangFuse, for example, for the project, you can basically take one of our examples here, if I find the tracing here. So these are some of the examples I just ran right now. So you can ask a question, and you can basically trace your question and answer through LangFuse, and we can do more complex tracing, and a lot of that is also scaffolded in the tool. Going down here, what are some things we are looking to do is basically each LLM has certain limitation when it's consuming tools. Some have number of function calls, length of the function call, or parameters, and the amount of description you give because of the context window. We're all doing context engineering. That's another thing we wanted to improve on. Token count optimization, as well as include like a validated set of prompts that we think work for us, and also resources. And in potentially, right now this is generating Python code, and there are pros and cons of doing that. We also want to explore if we can enhance the OpenAPI spec itself. One of the difficulties today is the OpenAPI spec as is does not work well, and it has like Swagger 2 to Swagger 3 type limitation. So we want to see if we could just give an OpenAPI spec to something like Agent Core or Gateway and the Gateway solutions. Last but not least, so there is our projects here, AI Platform Engineering and OpenAPI MCP Code Gen. We have a workshop coming up, hands-on, it's completely no obligation. Feel free to join that. It's coming up in a week, 10 days. So a QR code is available, and we'll stop here and take any questions.
Or you can take a picture. Any quick questions before we end? If not, we'll be available outside. Go ahead.
How do you deal with authenticating to some of those platforms like PagerDuty and different things?
Yeah, it's a great question. Yeah, so the question is, how do you deal with authenticating with some of the MCP servers, or like PagerDuty or even AWS. So it's an evolving science of like doing user delegation or impersonation. Right now we're using service accounts, and we're in the scope of what we're doing, we're trying to identify how we do agent-to-agent identity. And there are some stuff that the incubation team I'm part of, like Outshift, is working on, as well as the overall industry. There are many community groups that are working on how do you take user context identity and map that to basically like your third-party services. So how do we do token exchange? I think we're kind of in the forefront of this. In some ways, we have taken the service account approach, but that's definitely not scalable.
Like in Argo, will be like a token, right? In Argo CD, you can create a token for a service account that usually use from Jenkins or Cargo. You can configure that to the MCP server, so it becomes a service role.
Yeah, I think many of our current use cases there are certainly create use cases. Many of them are troubleshooting, so there is a lot of list and get. But even in those circumstances, we want to do the right RBAC or task-based authorization. Yeah, great question.
Okay, one more, and then go ahead.
Yeah, so the question is, how are we basically managing the gateway with multiple MCP servers and agents? So one of the things we did in CAPE is that all of these agents are domain-specific agents, so the context is managed within the agent itself. So CAPE is an orchestrator, and it orchestrates like we have 14, 15 agents, and we're growing. We're also adding a lot of enterprise agents. So it basically orchestrates all of that remotely, and the context is managed within the agent, and CAPE is kind of supervising these agents. That's the architecture we followed to essentially, to your point, of mitigating the context of like so many tools within an agent, and it can get pretty complex.
Yeah. One agent with too many tools, it gets confused. So we're building a multi-agent system. So So it's agent to agent, talking to itself to fix the problems. Yeah. Thank you so much for coming.
Thank you.